All right, guys. So we started a new one class at the end of class. You didn't get any homework around the board. So we're just going to continue with some examples like this. Morning. All right, so last week we did an So typically, guys, what Mr. Keith usually do, or what I've realized is that anytime you get an equation or an expression that has both sine and cosine on it, and none of them were actually squared, then it's a potential question that involves this form, right? But when that expression starts with sine, they usually put it in the form r sine. If the expression starts with cosine, they usually put it in the form r cosine. But it doesn't restrict you, it's just something that they would have adopted over the years and they seem to stick with it. But any equation that has sine and cosine, you could see that because addition is commutative, you could flip it around, and that rule is out of the park, you know? So this is a question that Mr. K could ask. This SS style question. How do I answer any question that asks me to put A sine of an angle plus B cosine of that same angle in the form R sine or R cosine X plus alpha? Because they tell me that this is in the form of that means at some point they are equal. It's just a template, and we start out by saying let my expression as given be identical to what I'm trying to put it in the form. Just like the template last week. That's all? Then we need to expand this thing using compound angle formula. Be careful. How do I expand sine? Sine start with sine of the first thing, but sine alternate cosine of the second thing. Sine keeps the sine, so that's a plus. Cosine of the first thing, sine of this. So this comes down to 2 sine x plus 3 cosine x being identical to the distributive expansion r sine x cosine alpha plus r cosine x sine alpha. Yeah? After you have expanded completely, that means no more brackets, then we equate coefficients. What are we going to always equate coefficients of? We will always equate coefficients of sine first and then cosine after, or vice versa. But equate coefficients of both of them. But remember what equate coefficients mean? So let's say equate coefficients of, let us say we're looking at sine first. We could have looked at cosine first, it doesn't matter. Alright? If it is, I will look at sine x. On this side, what multiplies sine x? So 2. And on this side, what multiplies sine x?
R cosine alpha.
Then I can call that equation 1. And then cosine x, what multiply cosine x on this side? 3. And on the right hand side,
R sine alpha.
see, I just underline that thing and multiply it. Yeah? So this is R sine alpha, and that's my equation. Now what do I do with these two equations? Which one have sine in it? 2. So now I'm going to say 2 divided by 1. Remember, anything that has the sign, I will put as the numerator. You know? So in this case, this would be 3. So this is first, I will do this. This is what I always do, you know, sine upon cosine. Just in case you want to remember, it's always sine upon cosine that I'm trying to build. You know?
Sure.
So that I can get tangent. That's all? All right. So this is, I will write the triptychs first. So this is R sine alpha equal to 3 all over R cosine alpha equal to 2. Yeah? So in that case, you see the R is cancelling. So this becomes tangent of alpha equal to 3 upon 2. Then alpha is equal to tangent inverse of 3 upon 2. What is that, guys? To 1 decimal place. If I'm dealing with angles in degrees. What do we get?
56. So what should
56.3 degrees. Oh. Right here, guys, R is always going to be greater than 0. That's just usually part of the question. And alpha is usually acute. Right? So that's a nice check. Alpha should come out to be acute. All right? Less than 9. Having done that, then I need to say second. So it's always the same step. I always try to put sine upon cosine when I after equate coefficients. And then I always square the 2. 1 squared plus 2 squared, and I add them, right? So in this case, this would be r squared cosine squared alpha equal to 2 squared, aka equal to 4. R squared cosine squared alpha is equal to 3 squared 9, and I add. When I do that, you can clearly see that I get r squared. Can I skip a step on it? R squared is clearly common in both of them, so I can factor the r squared and add. That's all. Can you see that? Equal to 13. So this is r squared times 1 equal to 13 because sine squared plus cosine squared of that of a similar angle, same angle, is equal to 1. So this is r squared equal to 13. R is equal to root of 13. Note that this is always best given as the exact value, which is why we did it this way. Instead of re-substituting this into one of these equations, which you could have. Fair enough? Right? Especially since this would be more likely a rounded answer. You don't want to plug in a rounded answer in any other equation.
Sir?
Yeah? You're not seeing it?
No, we on the other side, I explain because I didn't see why.
Come over this side. Let's go over this side. Because, all right, I'm all right, and that's more. Alright, ready again? So I'm going to walk through the whole process one more time. The man said, write 2 sine x plus 3 cosine x in the form of r sine in bracket x plus alpha. Okay? That means the first thing I need to do is let my given expression be equal to that form. So that's the first thing I do all the time. Then I expand like I know how to. And the only thing I see there is a compound of the formula. So I expand whether I look at the formula sheet or remember it. It is in bracket that sine x plus alpha needs to be expanded. Sine, start with sine, so it is sine x, sine alternate. So sine of the first thing and cosine of the second thing. Sine keeps the sign, that's why it's a plus still. Cosine of the first thing, sine of the second thing. When I expand using the distributive law, R will see this, R will see that. And I write this one so that I can equate coefficients. Right? First thing I will always look at sine and cosine, but not of the alpha of the x, right? The one that's on both sides. In that case, I will get 2 because 2 multiplies sine on this side, and r and the cosine alpha multiplies sine x on this side. Okay, so that's what it means by equate coefficients, right? Whatever multiplied the respective term on either side, those must be equal. Right? For me to say the 2 expressions were equal to begin with. Yeah? Then the cosine x, what multiply cosine on this side, it was 3. What multiply cosine on that side, you can clearly see that the r multiplied here and the sine multiplied. So r sine alpha multiplies. And then r with little line equations. Fair enough? Having equated I would always get an equation with cosine and sine. I need to put the equation with the sine up top and the equation with the cosine down south so that I can get sine upon cosine all the time. In that case, you can see that the r is cancelled and I'm left with sine alpha upon cosine alpha, that is clearly tangent alpha, equal to 3 divided by 2. Then this looks like a regular equation, right? At this point, you just see tangent invert up that thing, and I get my alpha. You follow that so far? Everybody else follow that? Yes. All right. Then the second thing, I will not take this equation, this answer, and plug it back into any of these. Why? Because this is a rounded figure to begin with. If you have a fancy calculator and you know how to use the calculator properly, then you can feel free to use the exact value. So if you never round off, you can just use it back if you want it. But I would just say, don't bother with that. You always just square the two equations and add them. When I square them, look what happens. I will always generate sine squared and cosine squared, and multiply the sine and the cosine is the same thing. Therefore, it will be the use of my most important identity, sine squared plus cosine squared equal to 1. Right? That making sense? So this would have been r squared cosine squared alpha plus r squared sine squared alpha, a factor of the r squared, leaving with sine squared plus cosine squared. Yes? That in brackets is 1, so I get r squared equal to 13, r is equal to root of 13. Right? Then I need to summarize at the end. Then I need to say, therefore, twice sine x plus 3 cosine x is identical to, and it was r, but what was r? Root of 13 sine of x, and what did I find my alpha to be? 56.3 degrees. That's answer part 1. Okay. It's very, very, very template-ish, right? There's no deviation from this template. That's the beauty of it. So you don't need to go and study 15 times, right? Before I answer these 2 questions, I'm just going to give you the only thing that Mr. K can ask you about. You know, as a theorem, so you can always apply that and everything should be all right. So I've lost anybody, right? Those 2 steps are the most important to remember, so that you can always get the correct answer. Just remember these 2 questions. I'll ask you for them a little bit, all right? Is that true? Remember that sine theta, sine of any angle, sine of any angle has a maximum value of 1 and a minimum value of -1. Isn't that so? If you remember the graph. What's up? Therefore, r sine theta will have a maximum value of r times, what is the maximum of sine? +1. Therefore, that is the maximum value is always plus r when you put it in that form. Know that there's no way for you to tell me what the maximum of this graph is. You don't know. You don't even know what the graph looks like. You know? Yeah. But I could tell you what this graph looks like. Yeah? Even with the very limited experience you have with graphical transformation. Remember when I tell you that, let's assume that x plus alpha is, this will only affect my x coordinate, my x direction. Right? So it doesn't affect my y value, which is my function value. So I don't care about this. This is what, anything outside the x bracket will affect my y direction. So you can see that, and I told you that multiplication means a stretch. So if this had a maximum of 1, the y value was 1, then the y value will now be r times 1. Can you see that? And if the minimum value was -1, then it should be r times -1, that gives me the new y, maximum y value. So sine theta has maximum of 1, therefore the maximum of r, therefore r times sine alpha will be r times +1. So also r sine theta will have minimum of what? R times -1, which is clearly -r. So when you put it in this form, that's the beauty of it. You will always get plus r to be the maximum, minus r to be the minimum. But that's the minimum function value or the minimum y value, right? Sometimes they will ask you, what is the x value that will give you this maximum r? You know? But what was the condition for this to be maximum or minimum? It was the only thing that dictated this maximum or minimum was not the r, no. It was this. It was when sine was maximum. When was sine maximum? When sine theta equal to 1. So I need to find what the value of that angle is at that point. I will show you that later on. Would you also agree that cosine of any angle has maximum of +1, therefore r times cosine of any angle will have max of +r as well, because it will be r times +1. Remember, I tell you that r is always greater than 0, that's the whole point. So this is now going to be +r. And r cosine theta will have minimum of r times -1, because cosine theta has a minimum of -1, so that is -r. So you realize that both forms, r cosine theta plus alpha or r sine theta plus or minus alpha, will have minimum of -r and a maximum of r. So that's when they ask you that in the exam, it's a giveaway mark. That making sense? The third question is not very much a giveaway, but it's a template nonetheless. So let's see how we'll answer part 2 and part 3 together. Yeah? So all of that was in boxed up to make a note of it. Right? So we're back to solution 2. this says find. The question could have very well said state the maximum value, because it's not thinking it taking. Right? It's just something you recall. Find or state the maximum value of f of x equal to 2 sine x plus 3 cosine x. But the man did say hence. Why is that important? Hence usually mean you would have just done up top, right? It did not say hence or otherwise, so you have no option at that point, right? Look at this function. In other words, can I sketch this graph? And you must tell me no, I cannot sketch this graph. Because I will know what sine look like and I know what cosine look like independent of each other. I don't know what they look like when they add to each other. So from 1 just done is that 2 sine x plus 3 cosine x is identical to root of 13 sine of x plus 56.3 degrees. That's guaranteed. Therefore, f of x can be rewritten as root of 13 times sine of x plus 56.3 degrees. So what's the maximum? Maximum of f of x is equal to root of 13 times 1, which is equal to root of 13. Since, and you don't need to write it, if the man asks for an explanation, you'll say it is because this has maximum. It doesn't matter what sits inside as an angle, because if x was 100, 156.3 cannot surpass positive 1 and can be less than negative 1. So it doesn't matter what sits in here. Sine of any bracket is always capital 1 or capital down south as one of minus 1. So you say since sine of x plus 56.3 degrees has max of positive 1. So that's easy. So what's the maximum value all the time? Is always whatever you find for r. What's the minimum value all the time? Whatever you find for the negative of the r. So part 3. Part 3 says hence or otherwise. In this case, there is a valid otherwise. Hence or otherwise, solve for value or values of x such that 2 sine x plus 3 cosine x is equal to, what did I say it was? Oh, no, I didn't say anything. My bad. And so otherwise, find value of x such that f of x has minimum value. So the first thing I need to say is, what's the minimum value of this thing? So the solution, what's the minimum value of, what's the minimum of my f of x in this case? It's the minimum of 2 sine of x plus 3 cosine of x, which is clearly the minimum of what can I write this as? Because I don't know what the graph looks like, therefore I cannot tell you what the minimum is. You see, if I cannot sketch it, I cannot tell you what the maximum or minimum is. Yeah? But this one, I know that is equal to root of 13 sine of x plus 56.3 degrees. So that's the minimum. But what's the minimum? Is equal to the minimum now. My root of 13 times minus 1, which is minus root 13. You know? Look at what will always happen. So what do I solve? Guys, in the exam, I don't need to go through such detail. All I need to say is that I'm solving this. Root of 13 sine of x plus 56.3 degrees equal to minus root 13. Look at what happens. If I divide both sides by root 13, would I not just get sine of x plus 56.3 degrees equal to minus 1? So it was sufficient then for me to just say to the examiner, hey, Mr. Examiner, I know that this equal to root 13 times sine of x plus 56.3 degrees from part 1. I also know that the maximum of this function, when it's in that form, is always determined by the maximum of this. So I could have just said that the maximum of this function occurs when sine of x plus 56.3 degrees is equal to minus 1. Sorry, the minimum. Yeah. The minimum occurs when sine of x plus 56.3 degrees is equal to minus 1. That making sense? So I could have skipped everything and just start here by just telling the examiner that I recognize that the minimum is determined when sine of anything is equal to minus 1 in this case. Fair enough? So this is all I need to solve. But we know how to solve this from many weeks ago. That's all? So how do I solve that? We have two ways of solving it. Remember. What's the method I tell you to use though? How many ways can we solve for all values of a variable that is in our trigonometric equation? When I'm talking about all values.
General solution.
I can find the general solution, but irrespective of the general, but that's one. I could find a general solution if they had asked to find a general solution. But we can find specific solutions, right? But what are the two ways we can find specific solution? I can use my quadrant system, or I can use my graph, right? When sine of anything is equal to minus 1, 1 or 0, I say that it's easier to use the graph. That's what we said, eh? That's true. Right? So, by use of the graph, I could see it. I can sketch the graph one time. At 270 degrees, that is when sine is negative 1. It's not so. Not so? Therefore, x plus 56.3 degrees, know that the answer is always for whatever sits inside bracket. So that is equal to 270 degrees. That's all. And there's only one answer between 0 and 360 degrees. I should have scaled it down. And the range was 0 and 360. Yeah? So in this case, because only one value, I would get x equal to 270 minus 56.3 degrees. What is x? In this case, 200 what? Huh?
More than 3.7.
That's correct?
Yeah.
Let's see if we can do one on your own. All right? Yeah, man, I'll wait.
You see, I really don't think you need to see more than a couple examples, literally a couple examples for this. So I'm going to give you a question now and then we are going to go through it together in class, all right? So I'm going to give you around 5 minutes to do this.
Okay, guys. I'm not going to tell you which form. I'm going to ask you based on what we discussed. What form would they likely ask you to put this in? Remember, it can be r cosine, because the angle here is x, be x plus or minus alpha, or r sine x plus or minus alpha. So I want you to help me with this form. So we don't know what they're asking about, but let us see. Which one would they likely ask to put it in? R cosine or r sine? Cosine, because things are with cosine, right? So I know that they want me to put it in the form of r cosine x plus or minus alpha. But in the exam, they can't ask about plus or minus. They must tell me which one of them. Which one would it be? Why?
Positive.
We'll go again.
Because being able to have positive cosine,
That's not the reason.
what is plus?
I don't know. Because you don't give a valid reason here. Who else want to add? Well, you want to adjust that answer or you want to change your answer?
Because the sign changes, that's why.
That's the reason. So it is plus. Note that if it was minus, when I expand cosine throughout the question, cosine usually changes the sign to plus. So it would coincide with what is given. So that's why I know that it must have been plus. You know? If they tried anything else, by the way, r or alpha, r might not be greater than 0, and alpha might not be an acute angle. But they want those conditions to be to hold. You know? If it was sine, then the signs would have to match. Yeah? Yeah. All right. You see the telling, you know, where r is greater than 0 and alpha lies between 0 degrees and 90 degrees.
Meaning it's acute.
B, they say hence, that means don't try anything else at home. Hence, solve the equation 7 cosine x minus 24 sine x equal to 4, and they're telling you that that is for x line in the interval, including 0 and 360 degrees. And finally, C, identify the maximum value of f of x and the value or values of x where this maximum occurs. All right, 5 minutes. That's how Mr. K can answer about this template library. And it almost always comes. Therefore, go in prepared to answer and receive your 3 marks. All right? Let us see what you make of it in 5 minutes. Starting now. Guys, I've just been told that you guys don't register for the exams yet. What are you waiting on? Okay. When is the deadline? Let me see if you even remember. Oh, cool. So at least we know the deadline. So you have to remember to do it. You don't want the headache of listening to it. Alright? If you have challenges meeting that deadline, you need to communicate that first. You know? So we're not saying everybody will have the resources to meet the deadline, but if we don't know, we can't provide for you. You know? Alright, great. I'll remind you again next week Saturday. At which time I would expect everybody would have either reached out to Martin Limited directly or saying that a WhatsApp. No. They never give me the date. They never give me a list of those from what we know that we're not at 100% yet. Right? For those who indicate that they're sitting the exam here. Right? If you're sitting the exam elsewhere, then you just need to turn up for class, that's all. Nothing else. You know? And please remind your friends when you see them. Right? You can discuss that over lunch. Alright? When you see them. On the other classes that need here. And CSET, if they're doing CSET as well, so registration date. Are we finished? Finished? Where are you stuck?
I don't want to do the wrong thing, so I'm waiting.
You know what? No, but all right. So when you go in the exam and you don't want to do the wrong thing, you wait on the English test system.
That's different. By that
You have
time,
to write in pencil or
by
something.
that time, I know the right thing.
Question. First step is respective to what the question begins with, right?
Go again.
The first step after evaluation, after each way,
Okay.
does it go in respect to what the question begins with?
No, it doesn't matter.
Doesn't matter.
No.
For the first one where we use our sign, and for step one, we said sign so I get it up.
It's always sign up on the top.
Always sign up on the top.
Yeah, sign is always on top.
Even when we use our cross.
Because we are trying to get content, right? I know some persons might not reach here in the video yet, but you have to just take what I said from gospel, like sign up and cross for the time, right? But that's what it be like in the first video, right, Natalie? You saw that in the first video? All right. When I said it looked like you never believed, that's why I asked you if you watch that video yet. General, or you can say. 5 minutes past, but everybody's still writing. I'll add 2 more minutes to it. These marks will not pass, but for this question, it won't pass 7 to 10 marks, so I don't think I can give you more than 7 minutes. Yeah? But to start operating within the time frame. Mhm. Huh? What I'm saying? Read the first word. What the first word says? Hence. You know, you leave your glasses every day. You leave your glasses every day. Or you need to go and get that glasses so you can leave it every day. Hmm? What the first word says? Hence. What hence means? In exam context, mean anything you do up top or previously, you must use that result. If you don't use the result, you may surely die. That's what it means. If they say hence or otherwise, then you may use the result if you feel like use the result. But typically, hence or otherwise mean you're best served using the previous result, but you can always find another method if you feel, yeah, so compelled. You know? All right. Lord, what is it looking for you?
Go forward. Not much. Don't worry about it. Wait. But you never squared them here either. That's what I was saying. When you got to this point, you just added 9 on square to get the 13. Okay. Yeah.
Mr. Trey, what is it looking for you? You finished? Almost there?
Just look.
Where you stop? But you're getting through it. All right.
You saw what expect to find the minimum value. So,
What did it say? Find what?
no, but I'm talking about me.
Yeah, he said nothing about minimum or maximum. All he said was to use previous results. So if you can't solve that question as given, you need to rewrite the question and see if you can solve it that way. But what are you going to use to rewrite the question? Must be part A. And then you see if that looks like a form. Yeah, you're solving for X there as well, yeah.
Do I have to use a graph?
You tell me. I mean, you can't look at it, you have to write it down and then chances are after simplifying, it may come to something that is familiar.
I don't know.
What did you do from part A? When did you walk in, miss? You were always here? How is he looking for you? Who's stuck on part B? Who's on part B or finished part B? Put up your hand. Tell her what they did for part B. To start, give her a hint. Don't give her the answer, give her a hint.
One part we're going to use what we equivalent to the seven costs.
We need the remember for our class.
Yeah, we're going to for our class. So we follow the tangent and the alpha, then it's equated to the seven costs, and then we take up part B. The seven costs.
So in other words, you're replacing. Remember when to solve an equation, typically you want to see one figuration.
Yeah. You put that equation, the one we just got.
So remember, part A is not done until I've done a summary, which is why I've done the summary. To see that 7 cos x minus 24 sine x is equal to r, whatever r is, cosine x plus whatever alpha was. Yeah. Let us see how we really approach this question in the exam, right? First thing would be to set 7 cosine x minus 24 sine x, that is f of x, to be equal to r cosine x plus alpha. Yeah? Having done that, I need to expand R in brackets. Now my cosine come in double and start with cosine. Cosine x. Cosine alpha. Cosine changes the sign from plus to minus. Sine x, sine alpha. Yes? Continue expanding. R cosine x, cosine alpha, minus R sine x, sine alpha. That was no trick. Then comes equate coefficient. Equating coefficient of sine x, I would get what multiplies sine x on this side. Be careful. Nuh-uh. Minus 24 equal. What multiplies sine x on this side?
Minus R sine alpha.
Minus R, and the sine alpha becomes minus sine alpha. Notice what happened. Minus divided by minus is a minus, or multiply the entire equation by minus 1. I would get positive 24 equal to positive R sine alpha. That is my equation 1. I will also equate coefficient of cosine x. What multiply cosine x on the left hand side? 7. What multiplies cosine on my right hand side? Cosine x, that is. R and the cosine alpha. There's a nice way to check whether or not you're correct in the exam. Everything comes to be positive eventually. Yeah? Yes? Then, whichever one of my equation has my sine, I need to put that on top. Because my one had sine, your two might have sine. So you would have used the appropriate division, right? I'm using 1 divided by 2 because my equation 1 has sine in it. So I'm going to get 24 equal to R sine alpha all over 7 equal to R cosine alpha. In that case, you see the R is going tangent of alpha equal to 24 upon 7. Therefore, alpha is equal to tangent inverse of 24 upon 7. What did we find that to be?
73.7.
Huh?
73.7.
73.7 degrees. That is great. So that is acute. And you see it satisfies. Good. Also, what will I do? What's the next step? I will always square each of them and add them. So let's square equation 1. Remember when I'm squaring an equation, I need to square both sides. 24 squared is what? That's a very big, ugly number that I do not know. 2576 equal to R squared sine squared alpha. And then 7 squared 49 equal to R squared cosine squared alpha. Add in will give me 576 plus 49, 625. That's supposed to look like a perfect square here. Yeah? R squared sine squared alpha plus R squared cosine squared alpha. That goes down to R squared into sine squared alpha plus cosine squared alpha. That goes down to R squared. So R is equal to the root of 625. R, note that they said R was greater than 0, so I will not say plus or minus root. Fair enough? What's the square root of 625? 25. in the exam, you would realize, like it's a multiple choice exam, while you cannot remember the formula for the alpha, I mean the angle, I can recall this formula, no? R is always the square root of a squared plus b squared. Yes? This one will always work. This one does not always work, right? So you'd have seen that R would have been equal to the square root of 24 squared plus 7 squared. And when you plug that in, look, especially in fancy calculator, if it was a root, you'll get exact value still. Clear? No. That's essentially what happens here. Know that I said I must summarize my answer, especially if it's an exercise question. Right? So, remember the question did not say find R and alpha such that this is true enough. They said put it in this form. So the examiner wants to see it. So this is now 7 cosine x minus 24 sine x is identical to R. What is R? 25 cosine x plus 73.7 degrees. So, in subsequent pieces of the question, anytime I see that, I can replace it with that. Right? Please remember the questions. I will ask for them. Yeah, raise this side. So everybody with me so far, right? Yeah. All right. Part 2. Oh, that was part B. I don't remember what that is. B. They say hence. Solve. For x within the interval 0 degrees and 360 degrees, the equation 7 cosine x minus 24 sine x equal to 4. That's all. Yeah. Here's the thing. There is a way, because remember the aim was to get one. I can't solve this. Why? Because it has two different trigonometries that I can't convert one to the other. Or so you think, right? So in this case, I need to rewrite this, but that look exactly, especially when I say hence, it gives me a cue to look into what I've done previously. You will say from a 7 cosine x minus 24 sine x is identical to 25 cosine x plus 73.7 degrees. Therefore, we solve 25 cosine of x plus 73.7 degrees equal to 4. Is that making sense? So far. I cannot solve this because it does not look like this. Why? Because there was something here. I need to get rid of that. So I divide both sides by . We agree? Yeah. Then I'm good to go. Yeah? Remember, I'm solving for all values of x. So I need to use my, not graph, because I can only use the graph when I'm when I'm solving cosine, when this is 1, 0, or minus 1. Now I've stuck with my quadrant system. Quadrant on the wall where is cosine positive. SATC. Know that positive cosine is positive in the first and fourth quadrant. But now I need to know what alpha is. What is my alpha here? Know that alpha is not that alpha, right? So what is that alpha? Cosine inverse of 4 upon 25. What is that, guys? What's this? Plug in the calculator quickly for me.
8.8.
80.8 degrees. Everybody got that so far? Solving this. And then I realized that that is regular method of solving for specific solution, whether by the graph or by the quadrant system. I realized that I could not with the graph, so I'm using the quadrant system. Cosine is positive, therefore the line in the first and fourth quadrant, and I find out what is here by saying cosine inverse of that. It's not so. Then I read out my solution, but know that anything in this quadrant is plus alpha, so I know that it's just so. But what is the solution? Remember, in this case, what are my answers? The answers are all for x plus 73.7 degrees. And that was in bracket. Fair enough? Equal to plus alpha. What was alpha in this case? 80.8. Or to read, I will move from my 0 to touch my first radius vector. You can see that that measures 80.8 degrees. But that's not the final answer. X is equal to 80.8 minus 73.7 degrees. So that is what?
7.1.
Huh? 7.1 degrees. That is one. Or note that this in this quadrant, remember, it's going to be 360 degrees minus alpha. And over here, so if something was over here, it would have been 180 minus alpha, and it would have been 180 plus alpha. You guys remember that then? All right. So here is 360 minus alpha, or you could have said, well, the touch is radius vector from 0 past 180 past 270 is almost 360 minus that little piece, or that big piece. So we want to. There's not going to be, but again, the answer is for x plus 73.7 degrees equal to 360 degrees minus alpha, which is 80.8 degrees. This is why it's important for us to know how to solve this from the get-go. We always spend so much time on it. Yeah? So what is that? Right here. 279.2 degrees. Therefore, x equal to, take this minus that is what? 2, 0, what? 5.5 degrees. Those are the two answers there. Right? And just to check one of them, well, unless you work properly, plug 205.5 degrees in this. You will get 7 times cosine 205.5 minus 24 sine 205.5. Plug it in and then see what you get. Means that's a calculator there? Where's the calculator? You have to get it quick, you know, because you have to practice with it. Can you imagine going into the exam and asking me invigilator for a manual? That may happen if you don't get it early. What do you get? Who's working it out for me?
What?
Huh?
What?
Corey,
What?
what are you thinking about?
What are you waking up?
Plugging in this answer just to convince myself that that is correct. Not that you will do that in the exam, right? Where's the calculator?
I think I left it downstairs.
You think you left it
Not
downstairs?
sure.
Oh, okay.
Respect.
I got 4.
Exactly 4?
Or 20.
But it's pretty much 4 because you're rolling it off here, right?
Yeah.
All right. 4?
Mhm.
All right. So that's what we approach that question. Everybody's clear on that method?
Yeah.
All right. And then part C says, what did part C say?
Minimum, maximum.
Find maximum value of f of x. That is technically C part 1, eh? So let's find that first, because we need to be aware of that, right? If they ask me to find 2 things, I would want to break it up so I don't answer one, and because it takes so long, I forget that there's a second part of the question. Fair enough? So find the maximum value of f of x. What's the maximum value of f of x? The maximum value of f of x is clearly the maximum of what? What is f of x? Let me see the link here. F of x is this.
Yeah,
But I don't even bother with that. I just jump straight to my summary. It should have been 25 cosine.
Yeah.
And I know the key was inside. Right? But just for the example, see x plus
73.7.
73.7. Then this is clearly going to be 25 times plus 1. So that is 25. That's the maximum there. That's the maximum y value. Part 2 says find the x's. That makes f of x max. I will say f of x is maximum when? What made f of x maximum here? Cosine of x plus 73.7 degrees equal to 1. That was what made f of x maximum. Everybody seen that? Not quite? I'm going to show you that. I'm going to get back to that same equation. F of x was maximum. What is the maximum value of f of x? 25. But f of x could be written as 25 cosine that equal to 25.
The maximum value of what is 25?
F of x.
Okay, yes.
But when did the maximum occur? I was suggesting that f of x is max when cosine of something equal to 1. Cosine of that very thing equal to 1. But if you're not seeing that clearly, you can say, well, what is the maximum value of f of x? F of x was first and foremost written as that. And the maximum value is 25. So can you see that cosine of x plus 73.7 degrees is equal to 1? In that case, when I divide both sides by 25. This I can use the graph for. But when is cosine equal to 1? When it's equal to 0 and 360. So x plus 73.7 degrees equal to 0 degrees. And x plus 73.7 degrees equal to what? 360 degrees. So in this case, x is equal to minus 73.7 degrees. Answer? Not an answer. Why? Because the interval says it must be what? Between 0 and 360. So x is equal to 360 degrees minus 73.7 degrees. What is that? 20. 286.3 degrees. Everybody's happy with that? And you can just do a quick check in the exam to say 7
times cosine of 286.3 minus 24 times sine of 286.3, and you see if you get 25 or approximately.
So in the exam, do we just do an X like that, or tell them that it doesn't lie within?
Not solution,
Okay.
or no solution, or not valid solution. Just let them know you cannot put that X. Put it in box and put that X right inside the box. Alright? So you know that that's not an answer. Fair enough? Any which way you want to convey to them that hey, Mr. Examiner, this is not an answer that I'm going to offer. But they need to still work nonetheless. Fair enough? Alright. Alright. So let me give you any more examples. I'll give you some for homework. All right? No. Who's still writing for that? All right, let me give you some time to write. Is everybody following so far? Trigonometry start from September. First of the last in August.
I know this, like,
No, we're just still on trigonometry. That's the topic. Still on trigonometry. So all the classes.
this is the last topic.
No, second to last topic. But the solving trigonometric equation is maybe the first 3 weeks. That is solving things of this form. But I don't want it to skip and go skip videos. I want it to keep in order. Okay, cool.
Quick off topic questions here. 10 square, 1 square, 6 square. That's 1.
Yeah. What he was saying is 1 plus tan square equals secant square. Right? I'm a sort, so I understand. Yeah, I understand what he was saying. No, I want to say yes, but I'm going to say no. I don't know why. Because I tell you, I must remember only this. And if I remember that, then I say, how do I get tangent that you wanted in that other identity? Tangent is sine upon cos. So this will tell me that I need to divide by cos squared. And in that case, sine divided by cos is tangent squared. Cos divided by cos is plus 1. 1 upon cos is secant. So yes, you are correct. But I don't want it to spell it that. Just remember this. Right? But if you want, it may be useful in the exam. Right? I'm just saying you have a lot of stuff to study, so you don't necessarily need to commit that to memory. Alright? It's a recap, but it's a segue into the next topic, right? Solving equations of the form A cosine theta plus B sine theta equal to some C, where C's are real numbers, right? As you realize, we technically did that in part B of the last example, right? So, method 1. with an example, right? Method 1 is identifying that it is in that form.
So for example,
two cosine 2x minus 3 sine 2x equals 2, right? Now, the first thing I would want to do as a sitting candidate is what? Recognize that it's not x alone that is right here. Fair enough? The second thing that I need to do, well, by the way, this is for x in the interval 0 to 360. Fair enough? So sorry. But this is the equation that I'm solving. First thing I need to say to myself in the exam is that, well, I know that when I'm solving an equation, I need to change everything to one single trigoration if possible. Fair enough? I could say, try to change that cos to sine, can't work, because it's not squared. Try to change that sine to cos, can't work. Try to divide everything by cos, not going to work. Yeah, more, because then cos will be over here and tangent will be right here. Two whole different trig ratio. So I recognize that this is in the form of a cosine an angle, where this is theta, plus or minus b sine of an angle. So it is in that form. So you have to recognize the form. Because it's not all the time, it's like when I say put in that form in stuff. Fair enough? So I recognize that this is in that form. So in doing that, I need to say first, I will express 2 cosine 2x minus 3 sine 2x in the form. And this is where we need to be able to build our own form. Right? So I need to put this in the form of r cos or sine. Which one would you put it in? Cos. Although you could put it in sine, there will be nothing wrong with it. Fair enough? But the convention is, if cos start the thing, put it in r cos. What is the angle, guys? 2x, not x. So please do not put x right here. You will die. Fair enough? So this is what? Twice x plus or minus alpha. Is this plus or minus? Be careful. Why is it plus? I expect that the cost will change it back to sine, to minus. That's all? That makes sense? Great stuff. So that's how you would have built your own question within the solution. Yeah? So I need to just get down to this business. So this is twice cosine twice x minus 3 sine 2x. Before I even continue, everybody understand why I would need to build it like this? Because there's no other way that I know of so far to solve this. What I can recognize is that this is in the form of a cos theta, where a is 2, theta is 2x. You see, it is in that form. So the same method that I will use for that form, I need to employ here. Fair enough? All right. So here, I need to set that equal to r cos twice x plus alpha. Having done that, I need to expand. R cosine comes in doubles, cosine twice x, cosine alpha minus sine 2x sine alpha. Then comes equating coefficient. Coefficient of my sine cancel equivalent of sine x. Because there is no sine x or cosine x to see. There's only cosine 2x to see. You know? So you have to adhere to the angle right through the question. So in this case, what multiplies sine 2x on this side? Can you see this minus 3?
Mm-hmm.
What multiplies sine 2x on this side? Minus r sine alpha. So in this case, 3 equal to r sine alpha. That's equation 1. Everybody following me so far? And then I need to equation of cosine 2x. But multiply cosine 2x on this side. 2. Or multiply cosine 2x on this side. R and cos alpha. And that I will call my equation 2. Then, same procedure, you know. 1 divided by 2. Why did I do that? Because 1 contains sine and 2 contains cosine. So in this case, I will get 3 equal to r sine alpha and 2 equal to r cos alpha. Can you see that 3 upon 2 is equal to tangent alpha? So alpha is equal to tangent inverse of 3 upon 2. What's it that again?
56.3.
56.3 degrees. So in this case, oh, by the way, what is my, how do I solve for my r now? Remember, it's always 1 squared plus 2 squared, no? That will always lead to what we can recall that by if you wish, or you can say what is 1 squared, 3 squared equal to r squared sine squared alpha, 2 squared equal to r squared cosine squared alpha. So in this case, you can clearly see that this is 9 plus 4 equal to r squared sine squared alpha plus r squared cosine squared alpha. Everybody following that so far? You can see 13 equal to r squared into sine squared plus cosine squared alpha. R squared times 1 is r squared equal to 13. R is equal to root of 13. Does that make sense?
Yep.
Right. Let's summarize this question together. Now here is over here. So here, so far, I would have said, therefore, twice cosine twice x minus 3 sine twice x will be identical to what? What is r? R was supposed to be root 13. In other words, just look on this. Cosine 2x must be there, and then plus 56.3 degrees. Remember, this is just interim answer. We're not resolving for x here. Fair enough? In other words, if I already know how to put this in this form, I guess the only thing that I need to remember here is that if I get cos and sine in the same equation and none of them is squared, I need to put it in that form. And then the rest will be history. So, okay, you would have been comfortable with this methodology before. So,
Just from the form.
yes, from this. Remember, they were starting off with this. So we are basically finding alpha and finding R. Yeah.
So they always tell you to express it in that form, or will they sometimes just write it down?
No. Note what the question was, all the question gave you, is solve this of the thing, full stop. It never tell you to express it. We recognize that it is in that form, therefore we need to put it in this form. So you are writing this, you wrote this, in the exam. And then you went and saw what you wrote. Let's go on.
No man, I understand all this.
All right.
But seeing the 2x, just because of
the
like the first thing that comes up for me is to do double or half, double and double that. That's the first thing that comes out today.
Why was this not requiring that method? Because the angles were the same. If one of them was x and the other one was 2x, the first rule of solving trigonometric equations are the angles must be agreeing. So in order to change the 2x to
one in terms of the other.
Right.
Okay.
So it's not just one trig ratio, it has to be one angle as well, remember? But if the angles were the same, I just go ahead and put it in that. Alright? No matter what, that's the next set of equations we're going to solve. Right? When the angles are not the same. Yeah? Yep, today. Alright. All right, so we have put it in that form. But remember, may I erase this side now, guys? Huh? You're finished with this side? All right. Everybody's comfortable with this type of solving? Because we just did it. It's just that the question may not explicitly say to me, put it in this form and then therefore solve. When they do it in that exercise style, they're trying to assist you. But sometimes they just throw you in deep end. And you need to recognize the form. Fair enough? Go again? Go again? No, that's a whole different kind of. It's not as complicated as this. It's a whole different form. Which way you need to recognize the forms, right? I have to show you how. No. Having done that, remember what was the goal? The goal was to solve 2 cosine 2x minus 3 sine 2x equal to what? What was it? Huh? It was 2? Mm-hmm. So, what I've just done was to rewrite this. What was this form to be? This was root of 30 cosine 2x plus 56.3 degrees equal to. Doesn't this look like something I made up in week 3 or 4 and tell it to solve? In other words, it wants to look like cosine of an angle equal to k. But it's not quite yet because this root 30 is prevented. It's not. So now I need to solve. For what? X lie between 0 and 360 degrees. How many sets of solution will I have here, guys? 2. Because this is amount of log 2. We have to get that, So this is 0 to 720 degrees. Because if x lies between 0 and 362, x lies between 0 and 720 degrees. Okay? 2 times around the mulberry bush, or at 360 to set 1. So, not only all of this is discussed in the videos, alright?
Okay.
Alright. So, what do I have here? I need to say quadrant on the wall, where is cosine positive? Again, positive here and here. Alpha is here, alpha is here. No, that is not the same alpha that I saw previously. Fair enough? Alright, it's reset. So, my alpha in this case is cosine inverse of whatever was over here. 2 over root of 13. What is that, guys?
Still get 56 points. So.
Go again?
No, mine can't be right. I'll still get 56 points.
Where you get?
56.3, I'm not sure.
56.3 it is then. Alright.
Yes? I would say yes, but here's the answer. Do I need to waste time doing that in the exam? No, because it's not a final answer. If it was a final answer, then I will to present the final acceptable form to Mr. Keep. But the hell with Mr. Keep until I don't submit my answers. Fair enough? Alright. Because the calculator will take it in. Right? So I do intermediate answers. I don't need to adhere to what Mr. Keep wants. Fair enough? Mr. Keep understand that and accept that fact. Fair enough? So it's 56.3 that we're here. That's all. If you guys correct. No. Then my answers, I need to remember so that I don't forget later on that I am having 2 sets of solution. Why do I have 2 sets of solution? Natalie, because this is a multiple of 1, cosine x suggests that is 1 times x, that means I have 1 set. That's how I get it. When I have like cosine 2x, I need 2 sets. And if I have cosine 3x, even if it's 3x plus 30 degrees or 3x plus 90 degrees, this is the general. And that tells me that it's 3 sets of solution. How do I move from set 1? I add 360 degrees to all my answers in set 1. And I add another 360 if it is that I needed 3 sets. Right? Now, set 1 is the regular method. Move from 0 degrees and touch my first radius vector. That happens to be plus alpha, whatever the alpha was. So you can clearly see that twice x plus 56.3 degrees is equal to 56.3 degrees. Remember, until I get all my sets, do not go and solve for x, those equations, right? Or twice x plus 56.3 degrees equal to 360 degrees minus alpha minus 56.3 degrees, because that's what alpha is. What did I get here, guys?
Division 3.7.
So these two
Set 1.
is set 1. So how do I get set 2? Natalie, watch. This is 56.3. So in set 2, I'm going to take all my answers that I got from set 1 and add 360 degrees to it. What did that come out to be? Huh?
Sorry.
400 and what?
16.3.
But I also need to add 360 to this one because this is a part of set 1 solution. But that come out with 663.7 degrees, right? That's correct?
Yeah.
Good. Then what? I need to remember that I am solving for x. So I need to go and transpose each of these. So you can see that here, x is equal to 56.3 degrees minus 56.3 degrees all over 2. That is clearly 0 degrees. Can you see that? Good. X equal to, transposing this. You don't need to play here and do it in one go like what I'm doing. Fair enough? You can do it in terms. By bringing over this 56 first and subtract and then divide both sides by 303.7 degrees minus 56.3 degrees all over 2. What did that come out with when you punch that in the calculator? 123.7. Somebody verify for your answer. Yes? Good. And x equal to, again, 416.3 minus 56.3 all over 2. What is that?
180.
Flat?
Yeah.
180 degrees. Point nothing?
0.3.
180 point what?
No man, yeah, 1 point.
Okay. Forgive me. All right. So x equal to 663.7 minus 56.3 degrees all over 2. What did that come out to be?
$303.7.
303.7 degrees. Great stuff. So those are my answers. 1, 2, 3, 4. Note that all of them fall within my required interval. All right. Guys.
Oh no, they're wrong. Okay, so example 51 in the book is incorrect, all right?
All right. What they did, they made a mistake and put this as minus, right? But it was supposed to be like that. All right, guys. But it's a typo more than like. Fair enough? All right. Then here's all of this. That was method 1. It just feel like a method 1. All right. Feel like this question must be done with and move on. Right? But this is method 1. Hmm? Go again.
Method 2 is 35 to solve it. Oh, okay.
Completely different method, different way.
You can choose which one you want to use.
Be careful. Method 1 will always give us valid answers. Method 2 will give us valid answers and sums. AKA, we need to go and figure out which one is valid and which one is not valid.
Which one is easier?
I'm different.
You choose method 2.
I really prefer this method
Okay.
because I have nothing to go and validate. What I get is correct,
So
guaranteed.
Why do I have a method 2?
Hmm?
Why do I have a method 2?
Because there's a method 2. May I erase the rest of this?
Is it the same question?
Same exact question, because we want to verify that these answers are the same. Yeah? Huh? SWOT? There's nothing in maths called SWOT. It means you know it. That's all. All right. Method 2 with an example. You're going to see that method 2 is very intuitive, by the way. Ready? What is this? What is the question again? 2 cos twice x minus, go again?
Minus 3 sine
3 sine twice x
equals to
equal to twice. What's the aim here, guys? If I'm solving, nothing. Forget that you even learned about a cos anything plus b sine that same answer, right? So we never have that at our disposal. What could we do? What is the aim in solving any trigonometric equation? I need to get one trig ratio. That means I must see if I can write everything in terms of sine or everything in terms of cos. But I just tell you that that is how we do it. It's not possible. But so now I'm going to suggest that this is possible. How would I get it possible? By getting cosine and sine squared. So I can maybe square both sides. Here's the challenge. If I have sine x, ready? Plus or minus cosine of x, and I square it. Let me show you what will happen. Ready? Using this method, sine squared. Middle term would be 2 times plus or minus, so it's plus or minus, right? 2 sine x, cosine x, and then the last term would be plus or minus squared. Anything that is squared is positive, right? Cosine squared x. So I would have gotten this, but guess what? I still have sine and cosine that is lingering. And it just makes our life more difficult because I could have changed this to 1 minus cos squared.
I have almost everything.
Almost everything. That's right, Corey. Almost everything. Right? So, how do I get rid of that? How do I ensure that I do not end up with the sine and the cos still? Or in a way that I cannot. If I ensure that sine alone is on one side and cosine alone is on the other side. In other words, I know that if I square sine and cos to get on one side, I'm not going to get rid of sine and cosine. In other words, I won't be able to change cosine and sine to only sine squared and cosine squared. So in that case, I would say twice cosine twice x is equal to twice plus 3 sine 2x. Let us try square both sides and see if we are going to get something meaningful. Ready? Square both sides. Square both sides will give me this. And let me not even play here and skip steps on it. Right? when I have this square, what would that be? I hear the answer under somebody right around here. What is it? 4 cos squared 2x. Remember, AB squared mean A squared and B squared. You know?
Why you don't square the 2 and x? Move the 2 beside it.
Because nobody can see that 2x, only cosine. So cosine x is a single term. So it's cosine 2x times cosine 2x is cosine squared 2x. You know? About in here though, using my shortcut method, I can say 2 plus 3 sine 2x times 2 plus 3 sine 2x. I use my arrow rule, that's all. But that's for you. 2 squared is 4 plus middle term 2 times this times this. Can you see that 2 times 2 is 4 times 3 is what? 12 sine 2x plus what? 9 sine squared 2x. Is everybody following so far? You're supposed to jump at me and say, I still get back sine 2x. But guess what? I never get sine 2x and cosine 2x. I only get one of them. So now I can change this to sine. And then everything is in terms of sine. So this is 4 into 1 minus sine squared 2x. Go again? I'm not hearing that question, but I'm coming back to you in a second. And I'm back. You see it now?
I was saying that I guess you're the 3 and get 12.
But you see it? Okay. All right. 4 minus 4 sine squared 2x. Naturally, that's the same thing as writing sine 2x in brackets squared equal to 4 plus 12 sine 2x plus 9 sine squared 2x. Then I need to group all like terms and bring everything to one side of the equation. Where am I going to bring everything? Let me see if you think here. Is this clearly a hidden quadratic? Can you see that?
Yes.
Good.
You bring sign over say positive.
Bring sine to which side? To my right hand side.
Yeah.
But I'm bringing everything to my right hand side. Because in solving polynomial, 0 must sit on one side. So if I bring one term to one side,
yeah,
I must bring everything to one side. But what dictates which side? I look at the term with the highest power, right? Because I wanted that to be positive.
Yeah. And
I will always write in decreasing powers of whatever it's a polynomial in. So this 9 sine squared plus 4 sine squared is 13 sine squared x sine squared 2x like this.
plus 12 sign 2x.
Plus 12 sine 2x. And thank God it's not a x squared plus bx squared plus c plus 4 minus 4 gone. Fair enough?
Yeah.
That's important, you know. That makes our lives much easier just now. Ready? I know that this I'm going to say let y equal to sine 2x to get 0 equal to 13y squared plus 12. 1. Is that good? So can you see that this is 0 equal to y into 13y plus 12? That's correct?
Yeah.
So either y equals 0, can you see that? Or y is equal to minus 12 upon 13. Are you seeing that?
Yeah.
Good. But y is equal to sine 2x. So it is sine 2x that is equal to 0. Or sine 2x is equal to minus 12 upon 13. Are we following that so far? Did I do it wrong? 9, and remember this 4 sine squared, come on one giant at 9 sine squared, and I get 13 of that sine squared. This go on a minus, but done, and the 12 sine still sits there. Then I take them in turn. How many sets of solution will I have? 2 sets, not just to see them. So in set 1, but I'm using the graph here, so I can sketch quickly what the sign look like. That's a lie. So where is sine equal to 0? Enough places. See, it's a problem. That's 0, 180, and 27, and 360. No? So it is twice x that is equal to 0. Therefore, x is equal, twice x is equal to 180, and twice x is equal to 360. That is set 1, eh? And in set 2, add 360 to each of these. So twice x, and twice x. Can I just pick up a calculator and add 360 to them? 0 plus 360 is 360. That's a repeated one. So I don't need to consider it anymore. It's repeated. Can you see that? Can you see that this matches this, guys? Good. So that's why I say repeated. I don't need to consider it anymore. 180 plus 360. In other words, just so you know, that's what I'm doing. 540. And 360 plus 360 is 720. So can you see my x is known? X would be equal to 0 degrees. Yes? X would be equal to 90 degrees. X would be equal to 180 degrees. X would be equal to 540 divided by 2 is what? Come on, guys. And x would be equal to? Great stuff. Over here, what do I have? To draw my quadrant system again. It's not so. Where is sign negative? Sign is negative where it's not positive. Yes? Okay. Sign is negative where it is not positive, eh? Alright? So, what do I have? Let's pause a little bit. Who is not following me so far? So all I've done was to rewrite it in terms of sine alone by bringing one trig on each side and squaring it. Then that will follow. Then all I'm doing is reviewing week 3 and week 4 with this. Correct? Alright. And this 2x means I need 2 sets of solution, and that's what I got. I used the graph because this was 0, 1, or minus 1. Sorry. Quadrant system is required over here. So what is my alpha here, guys? Alpha equal to sine inverse of what? Positive 12 upon 13. I never plug a negative in the sine inverse when I'm using the quadrant system board. What is that? 67.4. 67.4 degrees. So 67.4 goes here, and 67.4 goes here. Fair enough? So one of my answer, so step 1, will tell me that twice x is equal to 180 plus 67.4. What is that, guys? 247.4. and twice x is equal to 360 minus 67.4. What is that, guys?
292.6.
292.6. That is, so how do I get set 2, guys? By adding 360 to all of those. So twice x is equal to this plus 360. What is that?
607.4.
607.4 degrees. And twice x is equal to 292.6 plus 360. What is that? 652.6. Who's confirming those answers? Somebody confirm them quickly so before I move on. Who's doing it? I need somebody else to confirm it. Add 360 to these two and tell me what they are.
That's right.
The second one is also correct? Huh?
Yeah, that's correct.
Okay, great. Thank you very much. This is x equal to 247.4 divided by 2. What is that?
All right.
123.5. And this? Remember that all of these are 2x, right? So x is equal to 292.6 divided by 2. What is that? 156.3. 146.3. And this down here?
303.7.
303.7 degrees. And x equal to? Let's see.
326.3.
326 point. Great stuff. No answers will have here. But following that method, right?
Yeah, right. Okay. So that's it. That's what that one. The x.
Number 2x is equal to 247. So x is equal to. So how many answers did we get the last time? 4 alone. And now we get 10. Not 10. Somebody will repeat it. To be fair. 9 answers. That means some of them might be wrong. But which? Don't know. Let's verify.
So what I'm doing is use this.
170 there. So 2x equals 360.
Set 1 and set 2 pretty the same. So I don't need to consider both of them at the same time. You good, Chief? How will you verify these answers? By taking the x and painstakingly plugging them in the equation.
Well, guys.
Possibly, which is why if you say this method, using this method, I would suggest you leave it until the end of the exam to go and verify it and cross out each one. Fair enough? So you'd have gotten most of the marks already. Fair enough? What was the equation again, guys? Please help me.
The initial
2 cos 2x minus 3 sine 2x equal to.
So, what I need to do, if you were, know that because in my equation of 2x, if 2x equal this, if these are correct, then these are correct, right? So I would just verify to see that 2x says when I plug them in, give me the correct answer. Fair enough? So as to not waste time, because when I say cosine 90 times 2 is 180. That's all? So it's like plugging that. Fair enough? So what I would need to do to verify, I would need to say, is it true that 2 cosine 0 minus 3 sine 0? What is that? Plug that in the calculator. What is it? Huh? 2. Just to what in method 1, what were the solutions?
0.
Oh, 0 was 1.
Yeah.
Okay. I was a little concerned just now. Method 1, x was found to be 0. What?
123.7. 180. Should be done 3.7.
Are you seeing all of those over here?
Most.
123.7.
Yeah.
And we get 123.5.
Yeah.
It might be some running off errors.
Yeah.
Or you guys just lied to me. Now this is 247.4. I don't know how on earth doing it. Well, I don't know. Let's check. I just think that is incorrect. And suppose come to it 0.7. All right. So this is 123.7 degrees. All right. So it's seeing like we're seeing everything, right? We are seeing everything. So that's how we have verified that it's approximately 2. Therefore, this is correct. Fair enough? Then you go and plug in 2 cosine 180 minus, remember what you're checking here is the 90 degrees. So I'm checking 0. I would have checked 90 degrees. When I'm checking 90 degrees, you realize I'm plugging 180 because it's 2x that I need to plug in. Is 180 an answer? So I expect to get the correct answer. That's all. What is that? Plug it in real quick.
Minus 2.
You plug it in already? And you minus 2. Sure. Or 90. I'm checking and I expect it not to be a solution. You see how that works? You see how when I plug 90 into this equation, I get cosine 2 times 90 is 180.
Mm-hmm.
So you realize that it's not a solution, therefore, and I should have known from method 1 because it never showed up in method 1. Remember I tell you all what is shown up in method 1 is correct? It's like you do it method using method 1. You will always get the correct answer. No testing required. Fair enough? Alright. What about testing the 180?
Mm-hmm.
Then I need to plug in 360, right? So 2 times cosine 360 degrees minus 3 sine 360 degrees. What is that?
2.
We expected that 180 was the correct answer. Yeah. So now you see how you will have tested that, right? If times period data.
Which one?
Give me if it won't.
Which one?
Alright. I am gonna have to stop here. Alright. Hold on.
You guys trying to escape again? Now, you guys have to practice, whether or not to give you homework or not. But I did have homework in mind. Try these 9.5. And try it 9.6. Scrap that. 9.6. Yes, you will attempt 9.6. So that's 9.5 and 9.6.
And I should tell you that hopefully next week we can see trigonometry. Bye bye. Eh? Let's see what color.
Oh, Alright. Come in.
This technology always freezing on this here, alright? So alright. Corey. Justin. Justin has been studying some time now. Matthew. Or Randy. Kimberly. Lorian has been studying. Ashley. Crystal.
Yeah.
Crystal, when did you start? Huh? Michael? Gardner? Raquel? John Scolinas? Okay. Anthony? Monet? Trey is here. Alright.
good week.
Yeah, I'm sorry.
We are planning to have like all these something one of the days and all these Sunday. But there will be no class guaranteed between Wednesday and the 4th. So at least you get 10 days. But class hour, January 4th, I am just arriving. So no, not January 4th. Hold on, let me check. So there will be no class. Well, there will be no class at Christmas. That's great stuff. School starts back on the 6th for you guys. So you guys can take official holidays between the 25th and the 6th.
Okay, ready?
All right then.
Sure, we need to do steps.
A test.
And what about the fact that I missed some tests?
2 tests. Of course, I'm just fine on it.
Yeah, man.
No, these are the things. 1 second. I can give you the test anytime. I can give you the 2 test papers. Have you gone through those videos? Naturally. No, as in the first few.
In order.
Alright. So you should be able to do this question.
You nodded yes. You stop streaming to Eric, Sylvan.
Stop this one. Should I stop?